Welcome to Pre-Cal Trig. This is week 14, lesson 4.08. This is the last lesson, and we're going to be talking about the number E. Prior to class, you are asked to watch a few videos, and always you should, on Monday or the morning before your class session, your whole group session, review the vocabulary in Quizlet. For Unit 4, or for every unit, I add to this weekly. It has vocabulary, it also has formulas, a lot of important information that you may not pick up in your notes, but it's right there organized, ready for you to use. A couple of reminders before we start. For everybody, December 13th is the end of the semester lock date. Teacher graded work in my class will lock on 12/2, December 2nd. That means you can't turn in any teacher graded assignments after midnight on December 2nd. Late work retakes cannot be completed after the lock date. Teachers also will be out for state testing during the week of December 5th through December 9th. So we're almost at the end of the semester, guys. You've got Thanksgiving break coming up. I really want you to get a lot of things done before the break so that you can enjoy it. So we have one assignment this week. When we come back, we're going to be working on reviewing for our Unit 4 test. Here are a few reminders for everybody in every class. This is the information that I've gotten. If you're having a semester 1 final, to be exempt, you need to have a 75 or higher. The exemption date is November 29th at 11:59 p.m. So that means bring your grades up to a 75 or higher to keep from having to take that semester exam. The semester exam opens on December 4th at 11:59 p.m. and it's due on December 8th at 11:59 p.m. Teachers will enter zeros on December 9th, and of course, the lock date is December 13th. Again, look at the blue box. As a reminder, teacher graded assignments will lock in my course on December 12th. You can't turn in any teacher graded assignments after December 12th. Of course, if something happens and you have extenuating circumstances, communicate. Communicate to me privately and discuss what's happening so I can work on doing what I can to help you. Some things are not in my control, but those are the dates you need to keep in mind. End of semester is coming up quick, guys, and y'all are all capable of passing. Just need to get some things done and come in for help. Essentially, I'll be available this week and the week after Thanksgiving, but then I'll be gone for testing. So for semester 1, if you have an end of the year assessment for semester courses, our course is not a semester course, so this is just for your semester courses. Those assessments open up on December 4th, same as semester exams, at 11:59 p.m. They're due on December 8th, same date, 11:59 p.m. Teachers will enter zeros on the 9th, and the end date is on the 13th. All right, the intention is for you to have watched the videos that are in our course announcements. Also, I sent you these links in an email. I'm doing everything I can to get this in front of you, get you in the habit of getting ready and prepared to focus and start in class. I want to ask you what the number E is. So basically, we've been going over this, introducing it. Now we're going to go further in depth and use this to solve some real world problems. So there's going to be a lot in this lesson. We may not cover it all, but I do have a recording in the iCan that covers everything. All right, a logarithm is the inverse of an exponent. So what is a natural log? Or in other words, what is E? Well, if you watch, there's a really good explanation in the course, in the content, and in the links that I sent you. E is a number that's approximately equal to 2.71828, and it goes on forever. It never repeats, never ends. When this is used as the base for a logarithm, we call that logarithm the natural logarithm, and we write it as ln(x). So we're going to be practicing with natural logs today. Now, if this is new to you, there's nothing new about it. It's just the notation that we're writing it in. So please, please, please get into the course daily, especially for this unit, and practice until it start getting a better understanding of how to write this. We can't learn something overnight without getting into the course and engaging in the material. All right, everybody needs to go to menti.com and use the code 24642284 or scan the QR code and quickly put in, I want some input from everyone. Your name is not attached to this, just tell me what you know. Put in a couple of words. Our agenda this week, again, we're going to be covering the course content for 4.08. So on Monday, that was due at 4 p.m. Now, I know that you've got other things to do, so maybe you didn't finish taking notes, finish the practice, and maybe you didn't feel like you were ready to take your first attempt on quiz 4.08. But that was due at midnight last night, and the expectation is that everyone attempts it, even if you feel like you're not ready. Okay, it's not the time in the course to leave things undone. So if you've got anything that's overdue, get it done. And then you have 2 other additional attempts. So after you do that first attempt, I can look at what you know, and you can look at what you know, and we can just work on filling in and answering the questions to make everything more clear for you. But if you just avoid it, you're actually causing more stress and more work for yourself. So now's the time to be brave and get in and get things done. And so if you have taken that first attempt and you need help, then just bring your questions into Help Lab and we can quickly go over that together, and then you can take your second attempt or your third attempt. It's so much easier that way to have that first attempt done. And if you do come to Help Lab and you need an additional attempt, or maybe there's a question you can just talk me through to get extra points, that is so much faster than sitting there worrying about it and avoiding it. So there's not a lot I have on your plate, just 4.08 this week. Now you can start the unit review, but that's up to you. You don't have to go ahead and start that. So on Thursday and Friday, catch up on missing work and start getting your notes in order, getting everything ready for that Unit 4 exam. We'll come back and I'll have the review ready for you when we come back and all the support in place for you to take your not semester exam, but Unit 4 exam. So don't forget to get into our course announcements daily, get into the course materials, the online textbook, and practice. Again, the ICANN has the best resources. If students ask for something, I put the resources there. So there's more than enough. Plus, there are calculators that I've said that you can use there. If you're going online and Googling things, then you might get off track. You might get misinformation, and that would not be good. All right, I want you to go to www.menti.com and use the code 24642284. All right, before we start class, go to www.menti.com and use the code 24642248, or you can scan the QR code and put in a few words for what the meaning of inverse is. What is an inverse? Our agenda for this week, November 14th through 18th. Monday is the 14th, and you should have gone through the course content, the instruct piece, for lesson 4.08. You should be taking notes and completing the practice in the course in the instruct piece of 4.08 and taking your first attempt of the unit 4.08 quiz by midnight on Monday. That was yesterday or the day before, depending on when you're watching this video. And then on Tuesday and Wednesday, you're coming to live class. And you also have the opportunity to come to Help Lab at 4:15, from 4:15 to 5. So completing that first attempt on the quiz is very important. If you don't jump in and do it, whether you're ready or not, this is the part in the semester that you don't want to get behind. And I can help you if you make that first attempt. You also know what you need to go back and review or come in and get help for before taking the second or third attempt. So this week, remember, we're going to be focusing on 4.08. And then when we come back from the break, I'll have the review ready for you. Try not to get too far ahead of yourself. Wait for the review. Let's go through the review. And then you'll have 2 attempts on the Unit 4 test. The plans right now are that we will not have a semester exam, but you want to keep your grade up just in case that changes. But for now, we're not planning on that. So let's focus on Unit 4, getting caught up on all of your missing work, especially your unit tests. Those count the heaviest. Look at the course announcements for the Unit 4 review materials. Don't forget to get into the course and into the I CAN. Our target for today is we're going to be solving exponential and logarithmic equations, solving real-world problems involving logarithms, and you'll know that you have it if you can complete the exit ticket and participate during the lesson. Let's go back to solving logarithmic equations. Recall the one-to-one property of exponents. We have b to the x equals b to the y. What that translates into is the exponents are equal. So let me show you a concrete example. Let's change b to the number 2. So we have 2 to the second power and is equal to 2 to the x power. So it's clear for you to see, hopefully, that x would equal to 2. Both of these numbers 2 are being raised to the second power. All right, I want you to write down the one-to-one property of logarithms. We're going to be using this throughout the lesson. Let me get my ink color here. So the one-to-one property of logarithm states that if we write log base b, and then we have our statement here next to it, x, and we have the same, on the other side of the equal sign, we have log base b, same thing, and a different statement here. It's like the property of exponents. The x and the y will be equal. So how do we put that into play? Because logarithms are the inverses of exponents, we can say x is equal to y. We can identify that b is the base, and then y are the expressions, x and y, not the exponents in this case. But we have the same base. We can set this up and solve an equation as we did with the property of exponents. So let's see how that works. Let's take this example. Again, notice that we have log base b here, and on the other side of the equal sign we have log base b. So that translates into x equals y. So let's work out this example. Log base b 2x equals log base b x plus 7. So we have the same log base b. Let's mark through that and focus on 2x equals x plus 7. That's your equation. Subtract x from both sides. And let's look at what we have now. 2x minus 1x is x. X minus x is 0. Write your equal sign and bring down the 7. So we've solved that equation. So for this expression right here, I'm sorry, log base bx equals log base by, we can solve for x and get 7 when we're using that property for this example right here. All right, we have another example. We're going to use the one-to-one property of logarithms, so we haven't changed anything. We're just restating it. We're going to solve this equation. So let's evaluate and make sure that we have the same log base 3. We do. So we can take that out and solve this equation. X plus 2 equals x squared plus 4x minus 2. So I'm going to start by subtracting x and subtracting 2 from both sides. So I'm going to line this x that I'm subtracting underneath the 4x and line up the 2 that I'm subtracting underneath the negative 2. Let's just bring everything down. On the left-hand side, we have 0. On the right-hand side, we have x squared. We don't have anything to group that with. And then we have 4x minus 1x is positive 3x. And then negative 2 and a negative 2 is a negative 4. So now we have a trinomial that we can factor, whether you use your calculator or you put it into a t-chart to factor negative 4 into two numbers that multiply to give you, let's see, positive 4 times negative 1, multiply to give me a negative 4. But when I add those two together, they give me a positive 3. So those are my factors. X plus 4 times x minus 1 equals 0. So we can set each of these factors equal to 0 and solve for x. So for the first one, x would end up being equal to negative 4. And for the second binomial, x would equal to 1. Now we have to toss out the negative 4, because let's go back to what we learned before in units 1 and units 3. I'm not going to prove this to you right now. We've had enough practice with that, but this would give us an imaginary solution if we plug it back into the logarithm. Now we've got a lot of notation to learn. I don't want to move through and prove it to you at this point. Let's just take the short route. And remember to toss out your negative answers because those are going to give you extraneous solutions. So there's only one solution, x equals positive 1. All right, now I've shown the work here because my pen has not been working the best it could work. So I'm going to rework each of these to show you the work. Hopefully you can see it a little bit better, my writing. All right, so this equation matches the property of logarithms. So we set x equals to y. Again, this is our x and this is our y. Set up that equation, solve. Toss out the extraneous solution. So that's tossed out. Just mark through that. All right, now we're going to use the same property. Let's make sure that we have the same log base 3, and we do. So we set up the equation x minus 1 equals x squared minus x minus 9. And then we work on solving this by moving everything over to one side. So I'm going to subtract x and I'm going to add 1. So this is going to become 0 on this side. I'm going to go ahead and move it over to the right. Now remember, I subtracted x. Let me line it up over here, and I added 1. I'm going to bring down the x squared, and I'm switching sides, so keep that in mind. So I have x squared, and I have a negative x, and a negative x is minus 2x. And then negative 9 and positive 1 is negative 8. So now I have a trinomial. I want to work on factoring that. So use your calculator or use the t-chart. This is a simple trinomial. So I want two factors of negative 8 that add to give me a negative 2. So what multiplies to give you a negative 8? How about negative 4 and positive 2? Now, do they add together to give you a negative 2? And the answer is yes. So I'm just quickly doing the work for you. Again, we don't want to get bogged down in the algebra. So use your calculator. It's perfectly fine. You do know that you need to factor into these two factors, x minus 4 times x plus 2 equals 0. Set each of those factors equal to 0. X minus 4 equals 0. And x plus 2 equals 0. And we get two solutions. X is equal to positive 4 and x is equal to negative 2. Now, to save yourself some time so you don't have to plug these two back in and test them, just remember that your negative answers are going to be extraneous. So we've got to toss that negative 2 out. So our only solution is x is equal to 4. We cannot take the square root of a real number and get a negative answer. All right, just rewriting the work. I know it's kind of, my writing gets messy on the board, I'll have to admit it. All right, now we're going to use the property of logs, and we have all of those properties in the Quizlet study set. If you're not taking your own notes or you're not there yet, feel free to use that study set. And let me know if there's something that you need that's not there. All right, just like when we are taking exponents, let me give you an example. 2 to the power of 8. Let's make that an 8. Times 2 to the 5th power is equal to 2 to the 8 plus 5. We add the exponents when we multiply with the same base. Now, when we're doing the reverse or the inverse of exponents, we're looking at logs. We're going to use that same property. So think of it as when we're adding the exponents, okay, that's going to be same base, okay, like this. So let me show you how that works. So we have log base 2 and log base 2. We have an expression here on this line, x and 2x plus 3. But we're adding, okay, so what that means is we're going to multiply these expressions, x times 2x plus 3, before we start looking at solving this. So let's go ahead and distribute the x. 2x times x is 2x squared. And then x times 3 is 3x is equal to 1. All right, now this is where I want you to stop and look for a minute. How can I write this 1 in log base 2 form? Log base 2 equal 1. Look at that for a minute. All right, so this is where it's going to take a little practice. So bear with me. Did you see where I was going with that? log base 2 is equal to 1. So I'm going to substitute that in here. Log base 2. The way that we interpret that, let's go back to this. 2 to the first power equals 1. So I'm going to rewrite this as 2 to the first power, or just 2. Then I'm going to subtract 2 from both sides. So I'll get 2x squared plus 3x minus 2 equals 0. And I'm going to factor that into x plus 2. And I used a calculator for this. There's no shame in that. In fact, keep your calculators handy. Don't say you don't have a calculator, because you can always use Desmos. That's what we use in this course for a calculator, scientific, and for graphing. So now we have our two factors. This first one set equal to 0, and I get x equals -2. Now I can toss that out right away because it's negative. Now let's look at the second one, the second binomial, set that equal to 0. So I'm going to add 1 to both sides, and I'll get 2x equals 1, and then divide by 2, and I get x is equal to 1/2. So that's our only solution. Now if you're struggling with this, remember you've got this week and the holidays to go in and practice a little bit every day until that sinks in, because this is just new notation. All right, so I worked through this again, and I'm showing you all the steps, so maybe you can follow along. Just rewrote everything that I did here. Log base 2 equals 1. That means 2 to the first power. So I write that 2 to the first power right here. And then I move everything over to the left, factor it, set each of those factors equal to 0, throw out your extraneous solutions, meaning your negative answers, and we only have one solution here. X is equal to 1/2. All right, I went through this again step by step because I know that might have thrown you off interpreting what that 1 is on the right. If you have any questions, come in and get help. All right, here's a new question. We have the same log base 3 here and here, but they're not on the same side of the equation. So let me subtract log base 3 x from both sides. So we're going to get log base 3 x minus 6 minus log base 3 x equals 3. Now what this means is when you're subtracting, oops, I'm actually adding. If I was subtracting, it would have been division. When I'm adding, it's going to be multiplication like it was before. So we're going to cross out the logs, and we're going to take x times x minus 6, multiply those together. That's going to give you x squared minus 6x on the left is equal to 3. All right, now we're looking at 3 as log base 3. So let's set these logs that we have over on the left, log base 3. On the right, we have 3. So let's interpret that. Remember, we're going to go in counterclockwise. 3 to the third power is equal to, I'm just going to write that as 3 to the third power. And that's going to go right here. 3 to the third power is 27. So I'm going to subtract 27 from both sides. And now we have a trinomial that we can factor. X squared minus 6x minus 27 equals 0. That factors into x minus 9 times x plus 3 equals 0. Set each of those factors equal to 0. Here we'll get x is equal to 9, and here we'll get x is equal to negative 3. We're going to toss out that negative 3, and our solution is B, x equals 9. All right, just rewriting this, maybe it's not as messy and you can follow along. You can also download the notes in the iCan. Now we're going to move into some real-world problems, and we need formulas for this. So we're going to start off with the formula for interest. And the formula for interest, compound interest, is P equals 1 plus R over N to the N times T. Now let's pick that apart and identify what each of those things are. All right, P is the principal. The principal is what you start off with initially. So here's P. R is the rate. We've got to convert 1.4% into a decimal. So let's write that. Percent is divide by 100. So we're going to move this over 2 places. It's going to be 0.014. Just move your decimal places 2 places to the left. All right, we're compounding it monthly. And we need to know what term we have. Annual means 1 year. How many months are there in a year? The number of times you're going to compound that is 12. So n is equal to 12. We want to know how many years. That's our time. That's our time period. N is equal to 12. T, we don't know. And then the 8,000 is going to be A, our accrued amount. And this tells me that I've rewritten this. This is going to be times right here. The accrued amount is equal to the principal times 1 plus R over N to the N times T. Sorry about starting you off wrong that way. P, the principal, times 1 plus R divided by N times T. All right, so let's plug all of that in. And we're going to start with A. 8,000 is equal to P. That's what we start with, 5,000 times 1 plus 0.014 divided by 12 to the 12t. All right, so we just plugged everything in from that problem. All right, now you can use your calculator to simplify this. And I'm going to start off by dividing both sides by 5,000. So follow along with me. So this is going to cancel here, and we're just left with this part right here. We'll get back to that in a second. Simplify 8,000 over 5,000. I'm going to take out pairs of zeros. So I'm dividing by 10, 100, 1,000, and I get 8 over 5. And because I'm talking about money, I'm going to go ahead and convert to a decimal. Remember, we can carry it out to the hundredths place, like dollars. two places. So we're having to interpret our answer and how we express our answer. So 8 divided by 5 is 1.6. So that's equal to, and if I go ahead and simplify this using my calculator, I'm going to divide 0.014 divided by 12 and add it to 1. I get 1.00116, and I'm going to round that off right here because it just repeat. The 6's just repeat. All right, and that's to the 12t. Now, here's the clue. You're going to have to use logarithms when you have your variable as an exponent. We want to undo that. We want to do the opposite of that so we can, it's really, really hard for us to tell if we have something like, let me just explain. 3 to the x power is equal to 9. Now, if we know that 3 times 3 is 9, we could easily break this down into 3 times 3. And then we could write that as 3 squared, and we would know that x is equal to 2. All right, but we don't always have something nice like that. We might have 3 to the x power is equal to 17. And that's when we have to really use our calculator and our logarithmic formulas. And so that may take a little bit of practice. That's what the calculator's for. There's no number I can multiply 3 to itself that number of times and get 17. That's what I'm saying. All right, so let's get back to what we have here. So we're going to take the log of both sides. And when we take the log, let me stop for a second and look at this. It's going to be 12t times, we can pull this up to the front if we write this in log form. So I'm going to write log of 1.001167, and that's raised to the 12t. We can pull that 12 to the t out to the front. That's from your properties of logs. So getting in and practicing with that will help you to get this. And then over here, I've just switched sides. We have 1.6. We got to take the log of 1.6. All right, now I'm going to divide everything by log of 1.001167. So I'm going to divide it over on this side. Log of 1.001167. Okay, so on the left-hand side, I just have 12t. And then over on this side, it's kind of messy. I know I'm going to rewrite it on the next slide. Log 1.6 over log 1.001167. All right, so if I take the log of that number, put it in my calculator, I'll get 12t, and you're going to have to use a calculator for this, is equal to 402.98 and then I'm going to divide both sides by 12 to get t. So t is equal to approximately 33.6 years. All right, I know that's mind-blowing. And I have a lot of this written out in the notes. So if you go into the iCan and download the PowerPoint, you'll have the notes as well. So I've just redone all of this. hopefully so you can see it a little bit better. And now we're going to move on to the next example. Now this is the formula for, and I'm going to rewrite this because it may not make any sense at all to you. This is the formula for radioactive isotope and decay. It's not showing growth this time. It's going down from 21 to 17.3 rapidly as the radioactive isotope starts decaying after 45 days. So a sample originally contains 21 grams. So let's go back to our formula. The equation is given by A equals A O times E KT. So this is the initial amount of the sample. This is the final amount of the sample. And T is our time. This is our rate. K is our rate constant. And if we plug everything in, which I've done here, then we'll find, and we use our calculator, we find the logarithms. I think the easiest thing to do, because this is messy, is for you to download the PowerPoint and look at the steps. I'll try to walk you through that, but I know if you haven't really gotten into this, this can be a lot at the end. So take your time on it. All right. So the final amount of the sample, let me get my pen here, is 17.3. So let's remember where that goes in. That's going to be our A, 17.3. The initial amount is 21. That's what this is right here. T is 45 days. And K is our rate constant. And that's what we're trying to find. Okay, what is the half-life of the isotope? So we set that up. And I've tried to plug that in here. Now, E is a natural logarithm, so that's why I'm using ln. Remember, E is that 2.8 repeating blah, blah, blah number like pi. And then I solve, and I get 45K. And I ran out of room here. That's why I'm saying look at my notes. And we'll end up with 161 days. There's just not enough room on this slide. Try to start over and give myself some more room. But look at my notes. I think that's going to be quicker and easier. All right, what is the solution to this equation? I've already written on this because I can see that I have natural log here, natural log here, natural log here. Now, if you look at the right, I'm subtracting. So I'm going to go ahead and write these two expressions as division. So over on the right, I write ln of this expression and then ln of this expression. We're dividing this by this. And I went ahead and wrote ln, but those are going to cross out. On the left, we can take that 1/2 and we can put it over here. Okay, and just drop that ln. So we have x plus 26 to the 1/2 equals, after we have written this difference of squares as x plus 4 times x minus 4, you can see that the x plus 4's cancel, and all we have left is x minus 4 on the right, and on the left we have x plus 26 to the 1/2. Raising a number to the 1/2 means taking the square root of it. So I'm going to write that as the square root. Now, in order to get rid of that square root, I'm going to have to square both sides. So I square both sides, and that radical drops. So I get x plus 26 on the left. And on the right, x minus 4 squared is x squared. And we have a negative 4x twice. That's negative 8x. And then negative 4 squared is 16. So I went ahead and FOILed that out. And then I'm going to try to get 0 on this side. I'm going to subtract negative x and subtract 26. And I'm going to line up my x's over here. Put my negative 26 over here with the constant. And I get 0 equals x squared minus 9x plus, let's see, minus 10. X squared minus 9x plus 10, minus 10. And that factors into x minus 10 times x plus 1 equals 0. And the only solution that works when we substitute back in is going to be x equals 10. The x minus 1 we're going to have to toss out. So this is our only solution. Now we're going to use Newton's law of cooling. And this is a different equation, but it's the same thing. We're having to use logs because we're going to be looking for, what are we looking for, k or t? We're looking for one of those variables in the exponent. So the task is we have a cup of hot coffee. Over time, it'll cool down to room temperature. The principle of physics governing the process is Newton's law of cooling. It's a very common law that physicists know and practice with. I know it's new for you, but we're transferring what we know, logarithms, into real-world problems. And the more that you do it, the easier it becomes. And I know it's going to be difficult for you because it's something that you haven't done a lot of. So just push yourself to do the best you can. And guys, this isn't going to be everything in the course. It's just the end of the course. So do the best you can and don't let your fear stress you out so that you don't perform. All right, here's the formula. And I've walked through the next few steps, putting it into play. All right, so 5 minutes after we have our coffee poured, it is, in layman terms, hot lava. 10 minutes later, it's still hot lava, but it's cooled down. Our tongue just can't feel it. 15 minutes later, it's still very hot. Maybe not hot lava, we're exaggerating a little bit. 17 minutes later, it's literally ice cold. Okay, so how does that happen? That's an exponential and it's showing decay because it's dropping. It's not growing, it's dropping rapidly. All right, so the beginning of the experiment is when the time variable takes the value of 0. So we have f of 0. I know this doesn't make a lot of sense right now, but we're looking at this right here. F of 0 is equal to 110 e to the negative 0.08 t plus 75. Using your calculator, we get 185. The initial temperature of the coffee is 185 degrees Fahrenheit, a little less than the boiling temperature of water. Using that formula. Now, there's a bunch of letters, but we're basically doing the same thing. All right, I'm going to go through these steps again. To find when the coffee is 140 degrees, we want to solve. Again, we're using this formula. We subtract 75 from both sides and then divide both sides by 110, and this is what we get. By the definition of logarithms, this gives us this equation. So we're going to have to practice and go slowly until this makes sense. Dividing by both sides by negative 0.08 gives us a value of about 6.5 minutes for the coffee to cool to 140 degrees. The same reasoning gives an expression for time when the coffee has cooled to 100 degrees. This is about 18.5 minutes. All right, a couple more examples, just because I want you to have a lot of examples and don't feel like you're alone, but you have plenty of practice. Compound interest. So let's go back to our interest formula. All right, remember at the beginning, the accrued amount is equal to principal, that's the initial amount, times 1 plus r over n to the n times t. So let's take our initial amount, that's our principal, and plug it in here. Goes right here. Then we're going to multiply that times 1 plus. Our rate is 0.018 annual, so we're dividing by 12. And n is 12. We're looking for t. We don't know that variable. Okay, do what we did before. We're going to divide both sides by 4,000. Simplify that. We get 8 over 4, which is 2 right here. And over on the right-hand side, we have, maybe I shouldn't have used red. I have this left. And we're going to take the log of both sides. And we get, using our calculator, we get 38.5 years. And when you're doing these, read carefully how they want you to round. If it's money, you round to the nearest hundredth. Be careful about how you answer. All right, I'm just repeating what this formula is so you have it in your notes. What each of these pieces are, giving you this example again. The next step, think about practicing with taking logs and learning how to use your scientific calculator, how to use that log button. Know what ln is. It's just a common logarithm. It's Euler's number. I know in some of the tutorials they say Euler, but it's pronounced Euler, like the Houston Oilers. Maybe y'all don't know what that is, but I do. All right, so another example of investing, working through lots of notes. All right, so the next steps for you is to think about taking this week to slowly go through 4.08. Get it done, get it off your plate, and come in for help. I'll be available one more week after Thanksgiving holidays. Finish any course material this week for 4.08. If you have not completed your Unit 3 test, you must get that done. Please, please get that done. Even 20 points is going to make a huge difference on your unit test. Don't look for perfection at this point, but don't fail the course because you're trying to be perfect. Nobody's perfect. Just get it done. All right, look at the supporting material in the I Can. Finalize your notes for Unit 4 if I allow you to turn those in. Maybe your last chance for extra credit, but at least you can use your notes for your final test. So you want to start prepping for your final test once you've completed all your coursework, taken all your attempts on your quizzes. I'm not going to talk to you about the review till we get back from the holidays or the unit test. For the quizzes, if you don't do well the first time, then take the steps, come in and get help. Let me, talk you through some of the questions. I may be able to even give you a few points if it's simple mistakes that you made and you understand what you're doing. So let's don't get caught up in round emails because that'll wear everybody out and get you frustrated. So come in to get help this week or the week after Thanksgiving. Check the I Can. Lots of help there for you to work independently and asynchronously. If there's something that you need that's not there, just ask me and I'll do my best to keep collecting resources for you. I put this in the notes so that you could have this to copy down. We've been using these, so I just wanted to put them in front of you again. If what we were doing in class today didn't make a lot of sense, then you can see where those properties are coming from. But remember, you have a job to do to prep before you come in. All right, everybody needs to do the exit ticket. Go to joinmyquiz.com and enter the code 53119603. All right, remember, get into the course, materials, sign up for help sessions, or just drop in the links there, and the link to office hours, 10 o'clock on Monday and on Thursday. And the I Can is also there. That's where you find the I Can. All right, remember the lock dates on December 16th. Teacher graded assignments on December 2nd. Your teacher will be out on the 5th through the 9th. Check your email to opt in to small groups this week. We're going to be going over 3.06 and 3.08.